Fume hoods are one of the most important safety features in a research laboratory. The hood is used to protect researchers from breathing hazardous airborne chemicals, and the sash can be used for protective shielding. This video demonstrates how to use your fume hood properly to better protect yourself, your coworkers, and your environment from exposure to hazardous materials. When you use the hood, you should turn on the hood light so you can see clearly. All fume hoods are required to have a monitor showing if the hood is moving enough air to protect you adequately. There are three basic types of monitors on campus. Those with a magnehelic gauge showing the amount of air inflow, those with an audible and/or visual alarm that sounds when the face velocity is too low, or a combination of these two indicators. Some monitors also have a digital readout that shows the average face velocity of inflow air. Please familiarize yourself with the flow indicator for your particular hood and know what the normal operating parameters should be. This can be done by looking at the gauge itself or the hood certificate. If you see that the monitor is not working properly, notify your supervisor. If your alarm does go off, lower the sash and hit the reset button. This will generally clear the alarm. If lowering the sash does not eliminate the alarm, please don't stick a paper clip or a piece of tape over the alarm reset button. Something may be wrong with your hood, and you should report it to your supervisor and campus facilities immediately. Also check the Fume Hood certification sticker to ensure that the hood has been inspected and certified within the past year. Airflow turbulence at the front edge of the hood can push airborne contaminants out of the hood. In this case, the sash is too high, and when someone walks by, the low face velocity allows the vapors or fumes to escape out of the fume hood. Adjust the sash to the proper height. In this case, the glass sash was raised to the maximum working height as indicated by the joined arrows, then slightly lowered. Move extra equipment out of your way, and always work at least 6 inches in from the front of the hood. Large apparatus or clutter inside the hood can obstruct the airflow and allow fumes to escape. Apparatus should be elevated on blocks to allow air to flow underneath. When the sash is lowered, the capture appears better, but when the velocity becomes too high, research samples or tissues can be sucked up the hood duct. Properly adjust the sash and work further into the hood to protect yourself from inhaling hazardous vapors or fumes within the hood. Another very important benefit of the fume hood sash is it can act as a barrier to protect the fume hood user from any splashes, flying glassware, and possible fires that can occur in the hood. Some hoods, like this one, have a combination sash that can be opened horizontally or vertically. In this case, the horizontal sash is adjusted to provide protection from unexpected reactions or chemical splashes. Never place your head or upper body inside the fume hood while chemicals are present or reactions are underway. Doing so will defeat the purpose of the hood and possibly expose you to hazards inside the hood. Only place your hands and forearms inside the hood. Another type of fume hood you may encounter in many UC laboratories is known as a variable air volume VAV hood. These hoods vary the volume of air exhausted from the hood in response to the sash position, but maintain a constant face velocity of 100 feet per minute to meet Cal/OSHA standards. This has two important benefits. First, it allows for optimal hood face velocity regardless of the sash position. Second, VAV hoods provide significant energy savings by reducing the air volume when the sash is closed. It is very important for VAV hood users to keep the sash closed as much as possible while working at the hood, and to close the sash completely when the hood is not in use. Some VAV fume hoods have an energy-saving feature and are equipped with a zone presence sensor that is distinguished by a gray control box on the top of the hood. This sensor detects if a user is standing in front of the hood, and if no one is present, it reduces the airflow to an energy-saving or standby mode. The minimum face velocity is still adequate to capture fugitive emissions from within the hood, but not enough to overcome turbulence caused by an operator in front of the fume hood. These fume hoods offer additional energy savings when no one is present in front of the fume hood. The monitor panel on all VAV-controlled hoods has an emergency purge button, which increases airflow through the hood to maximum and can be used to quickly remove air contaminants from the fume hood. If you use the emergency purge button, close the sash to maximize removal of contaminants. Typically, there are no pollution control devices on fume hoods.
Fume hoods are one of the most important safety features in a research laboratory. The hood is used to protect researchers from breathing hazardous airborne chemicals, and the sash can be used for protective shielding. This presentation demonstrates how to use your fume hood properly to better protect yourself and our environment from exposure to hazardous materials. When you use the hood, you should turn on the hood light so you can see clearly. Check the hood certification sticker. It will list the date Facilities Management last checked the hood, the average inflow, and whether the airflow was satisfactory. One should always check the quantitative airflow monitor or alarm to verify that airflow for the fume hood is proper. There are several types of airflow monitors used on campus fume hoods. For this video, we will show you a few of those common types. Digital monitors display air velocity into the hood and should read more than 100 feet per minute. Some monitors will only display red, yellow, and green indicator lights. All monitors have an audible low flow alarm. Some fume hoods have differential pressure monitors that look like this. Since these monitors may be different from building to building, check with your supervisor for the correct meter reading. It should always be greater than 0. If the hood airflow monitor indicates low airflow, first try lowering your sash. If this does not resolve the alarm, contact your Department Safety Coordinator, EH&S, or Facilities Management for maintenance. Adjust the sash to the proper height. In this case, the glass sash was raised to the maximum working height as indicated by the joined arrow, and then slightly lowered. The tissue on the sash is drawn in, indicating that there is airflow into the hood. Most fume hoods now have this label on the sash frame. Be sure to use the sash in the green zone as much as possible. A sash should only be in the red zone for equipment setup. When you are finished with your work, be sure to lower the sash and save energy and protect lab occupants. Airflow turbulence at the front edge of the hood can draw airborne contaminants out of the hood. In this case, the sash is too high, and when someone walks by, the low inflow velocity allows the smoke to come out of the fume hood. Sashes properly adjusted and working further into the hood are the best way to protect yourself from inhaling hazardous chemicals used in the hood. Move extra equipment out of your way and always work at least 6 inches from the front of the hood. Some hoods have a combination sash that can be opened horizontally or vertically. In this case, the sash is lowered, then the horizontal sash is adjusted to provide protection from explosive reactions or chemical splashes. In older buildings, fume hoods may have horizontal sliding sashes and a velocity screen to meet the 100 feet per minute inward face velocity. Horizontal sashes need to be placed in front of the work and the velocity screen lowered to maintain a safe working environment. Typically, there are no pollution control devices on fume hoods. The airborne contaminants made in a laboratory hood are exhausted from the roof stack into the environment. Never evaporate chemical waste through a hood, and when working with a hood, minimize the volatiles released to protect our air quality. When you are done using volatile chemicals, close and seal the container. When finished using the hood, close the sash and turn off the light for added safety and to save energy. In review, before using the hood, check the airflow monitor. Properly adjust the sash height for your work. Always work at least 6 inches from the front of the hood. Fume hoods exhaust into the environment. Minimize your fume hood emissions. Close the sash when you are done working in the hood. In closing, if you have questions about your fume hood, ask your lab manager, Department Safety Coordinator, or contact the Office of Environmental Health and Safety. Also, read the fume hood safety net and other laboratory safety information available at the EH&S website.